This recording is to help you with lesson 2.07, Graphs of Rational Functions. Alright, we need to use a graphing utility to obtain the graph of each function and then give the domain, and then identify any vertical or horizontal asymptotes. So kind of a repeat of the last lesson a little bit here. We graphed this, and we noticed that there is a horizontal and a vertical asymptote. I will do the horizontal asymptote in light blue, or the vertical, sorry. That appears to be at about 1. And if we look, remember, vertical asymptotes are where your denominator cannot be 0, or where it would be 0, and that is at x equaling 1. And your horizontal asymptotes have that rule with if they have the same degree, then you take the leading coefficients. So you have -1 over 1. So you do have that horizontal asymptote of y equaling -1. And then your domain is very similar to your vertical asymptote, and that x cannot equal 1. So all real numbers except x equaling 1 for the domain. All right, using a graphing calculator here, there appears to be only vertical or horizontal asymptotes, no vertical asymptote in this one. And if we look, it appears to be approaching 2, 4, 6, +6 and -6, but it depends which way your graph is coming. So we do have those two horizontal asymptotes of + and -6. And for the last one, you graph it and we want to find the 0 or the x-intercept. Looking at the graph of this, your x-intercept is going to be a -4. But let's prove that algebraically. So we set our function equal to 0 and we're going to solve. The easiest thing here to do is, yes, you can find common denominators and multiply and everything like that. Or you can take the 4 over x and subtract it to the other side. Right? And I'm going to apply the negative to the 4. So I'm just going to rewrite it as -4 over x, because then we can cross multiply. So when we cross multiply, we get 1 times x is x, and -4 times x plus 5. When we distribute the -4, we get -4x plus 20. Or -20, sorry. Then we have to add 20 to both sides and subtract x from both sides. So you end up with -5x equals 20. And divide by -5 to get x equals -4. So that is how we can prove it algebraically.